Hi guys, welcome to Netgate Chemistry. So in the previous video of quantum, we discussed about the ground state of a particle in 1D box. So now we are going to discuss about the first excited state and we'll try to locate the maxima, minima and the node. So in case of first excited state, the wave function is root 2 by L sine 2 pi x by L. This thing we know. Now first of all, moving on to maxima. So we want to find out psi max basically, right? So where it will be, see again the value of this particular sine theta is maximum, that is 1, right? So sine is having maximum value of 1 because it has value ranging from -1 to +1, so it will be having maximum value of +1. So we will get psi max when the value of this overall sine theta, that is sine 2 pi x by L, is equals to 1, right? So this can happen when the sine is pi by 2, 5 pi by 2, so on, right? So if we try to locate the first maxima, so first maxima should come when sine 2 pi x by L is equals to sine pi by 2. That is 2 pi x by L should be equal to pi by 2. So pi cancels out with pi, right? And we get x is equals to L by 4, right? So at x is equals to L by 4, we will get the first maxima, right? So this is the first maxima. Now suppose this is particle, so this is the 1D box, right? This is x is equals to 0, this is x is equals to L. So this is L by 4, this is L by 2, this is 3L by 4 and this is L. So if this is L by 4, so here we are getting one maxima. Okay, now moving on to finding out the second maxima. For second maxima, sine of 2 pi x by L should be equal to sine of 5 pi by 2. So pi cancels out with pi, so you will be getting x is equals to 5L by 4, which is out of the box, right? So as we have moved out of the box, so now we cannot get any maxima. So now after this we will try to find out the minima. So for minima, see here for psi max will be root 2 by L because this will be having value of 1. For psi minima, this one will be having value of -1. So psi minima will become minus of root 2 by L, right? Now for finding out minima, this value of sine theta, it should be equals to -1. So sine of 2 pi x by L should be equals to -1. So that means sine should be having values of 3 pi by 2, 7 pi by 2 and so on, right? So now we want to find out the first minima. So for that, sine of 2 pi x by L should be equal to sine of 3 pi by 2. So pi cancels out with pi. So here we get x is equals to 3L by 4. So this is the first minima. right? So now we have got the first minima, which is at 3L by 4. So here if you look at this box, so here at 3L by 4, this is L by 2, this is 3L by 4. At 3L by 4 you will be getting the minima down here. So I cannot show it here, so we will show it afterwards. So now this is the first minima. We'll try to find out the second minima. For second minima, sine of 2 pi x by L should be equal to sine of 7 pi by 2. So from here 2 pi x by L should be equal to 7 pi by 2. So pi cancels out with pi and you get x is equals to 7L by 4, again out of the box, right? Out of box, because you will be getting here 7 divided by 4, 1.7 L something, right? So which is out of the box. So that's why we are having only one minima here. So we are having one maxima, one minima, and now we'll try to find out the node. So now discussing about the node, we know that the value of x at which psi, this wave function, is going to become 0 will be the point at which we will be getting the node. So basically sine of 2 pi x by L, it should be equal to 0. When it will be possible? When sine is having the values of 0 or any integral multiple of pi. So if we want to find out the first node, so what should be the case? Sine of 2 pi x by L should be equal to sine of 0, right? So from here you will be getting x is equals to 0 straight out. So that is a boundary. So here we cannot find the node, right? Again we'll try to find out the first node. So next will be the case of sine pi. So here sine of 2 pi x by L should be equal to sine of pi. That means 2 pi x by L should be equal to pi, or you can say x is equals to L by 2. So at x is equals to n by 2 we will be having our first node, right? With this we'll try to find out the second node. So for second node, sine of 2 pi x by L should be equal to sine of 2 pi. So from here 2 pi x by L should be equal to 2 pi. So this cancels out with this and we get x is equals to L. So this is also boundary, right? So we have reached the boundary. So one more case, sine of 2 pi x by L should be equal to sine of 3 pi. So from here you will get x is equals to 3L by 2. So which is out of the box. So we have moved now out of the box. So till now we have found only one node. So we have one node here. So how the wave function will look like? So suppose this is 0, L by 4, L by 2, 3L by 4, and this is L. So now what we have got is these are the boundaries, okay? These two are the boundaries. So because these two are the boundaries, so wave function will be 0 here. Now at L by 4 we have got one maxima. At L by 2 we have got one node at which wave function will be 0. And at 3L by 4 we have got one minima. Here value will be around -1, right? Multiplied by root 2 by L. And so if we plot a wave function, it would look like this. So forgive me for the drawing, but it will look like this, okay? So this will be the wave function for the first excited state. This is the first excited state, right? So Just like this, we can plot the wave functions for the various excited states. So basically, I know this is a long procedure, but in the next video we are going to discuss about the shortcut for this and also some of the important note points which you should remember for particle in a 1D box. So these are the things which you should know by now. So that's why we have discussed it in a thorough way so that you are able to understand how things work. But now we are going to discuss the shortcut for this. So that's the main reason why I discussed this overall, so that you are able to understand this quantum a little bit, because overall quantum no one has understood till now. So far I hope you are able to understand how to plot the wave function, how to find out the what is the exact method of finding maxima, minima and node. But now in the next video we are going to discuss to find out how to find out these things using shortcuts, and we will also discuss some of the important points regarding particle in a 1D box. So far I hope you are able to understand. If you have any questions, you can comment down below. I'll try to answer your questions. So far that's it for this video. Thank you so much for watching.